Hello friends, welcome once again to Edupedia Word Videos, your destination to free online education. In this video, we'll be dealing more with sectors and segments of a given circle. Let us have a question. Friends, the question says a cow is tied to the center of a square grass field which is 30 meters inside. That is, we have a grass field square in shape which is 30 meters inside. Now the cow is tied to the center of this square grass field that is somewhat over here with a 7-meter rope. We are having a rope of 7 meters and we have tied the cow here with this 7-meter rope. Calculate the maximum area cow can graze. We have to calculate the maximum grass that this cow can graze when it is tied with 7 meters rope. Now friends, the available grass is all the field, but we have a limit, a constraint. That is, we have rope which is just of 7 meter. Now the cow can move 7 meter here, here, here. That is, in the whole circular pattern, this circle, the cow can move with this 7-meter rope. So the maximum range is this boundary, and inside this boundary the grass can be grazed by the cow. So this, in short, we have to calculate this area. This is the maximum grass that the cow can graze. So this area will be the area of the circle, that is pi r square, where r the radius is the length of the rope, that is 7 meters. So we have pi into 7 meter squares. Now since we have 7 in numerator, so we can use the value of pi as 22 by 7 to simplify the calculations. So we have the maximum grazable area as 22 into 7 meter squares, that is 154 meter squares. The second part of this question says if the peg, that is the element with which the rope is tied with the ground, the peg is shifted to one of the corners, calculate the reduction of area. Friends, we have the circle. Now the peg is shifted to one of the corners, that is over here or here or any of the 4 corners. So now the rope will be like this and the cow will be tied somewhat over here. So the rope can make the circle like this. The cow can make its movement in this circle. So the available grass is only in this portion, and this portion is deprived of grass. So as a whole, we have to calculate this area. Now we know that this angle in case of a square is 90 degree. So this area OABC will be the area of this sector, that is theta over 360 degree into pi r square, the area of the complete circle. Now theta here is 90 degree, so we have 90 over 360 into pi r square, where r is 7 meters. So it will give us 1 by 4 into 22 by 7 into 7 into 7, which will give us 154 by 4, which is nothing but 38.5 meters squares. Now we have to calculate the reduction in area. The original area was of the total circle was 154 meters squares. So the reduction in area is 154 minus 38.5 meters squares, which is 5.5 meters squares. Now the third part of this question says, how much is the area reduced when the length is reduced by 7 by 2 meters? Now in the previous question, the peg was at the corner with the rope length as 7 meters. Now the length of the rope is reduced by 7 by 2 meters. That is, length of new rope or new length of rope is 7 minus 7 by 2, which is 7 by 2 meters. So now the length has become 7 by 2 meters. So the reduction in area will be this area. Now this portion, this brown portion is, say this area, the calculated in the second part be A2. So the reduced area will be A2 minus, if A2 is this 38.5 meters squares, minus this area, that is area of sector or quadrant OPQR. Now it will be 38.5 minus 90 by 360 into pi, which is 22 by 7 into radius square, that is 7 by 2 into 7 by 2. So we will get 38.5 minus this on calculation will give 9.625, which gives us the reduced area as 28.875 meters squares. So this was the first question on sectors and segments. The second question says, a design is made using a wire as shown. This is the design made that we are talking about. Calculate the total length of wire required and area of each sector of design. Radius is given as 50 millimeters and wire is also used for 5 diameters. Friends, we are given this design with the radius 50 millimeters. Now, in this figure, though there are 2 circles shown, but nothing is said about the other radius. So we will consider only one inner circle for our calculation purposes. Now wire is also used for these 5 lines, these 5 diameters. So for the first part, that is total length required will be the length of the boundary of the circle, which is perimeter of circle, plus the length used for 5 diameters. Now we know that perimeter of circle is 2 pi r, whereas the length of one diameter is twice of the radius, and we have 5 such diameters. So if the radius given as 50 mm, we will have the total length as 2 into, and pi is given as 3.14 plus 5 into 2 are 10 into 50. So we will have 3.14 into 100 plus 500. This on simplification will give us 814 millimeters. So the total length required is 814 millimeters of wire. The second question asks us to find area of each sector of design. So the area of each sector, what will it be? Friends, first of all, we need to know how many sectors are there. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 sectors in all. Now we know that this complete angle is 360 degree. So angle of one sector will be 360 degree over 10, that is 36 degrees. So theta is coming out to be 36 degree. So we have area of each sector as theta by 360 degree into pi r square, which will give us 36 over 360 degrees into 3.14, which is the given value of pi, and radius square, which is 50 into 50. 36 cancels 360 by 10, and here 10 cancels 50 by 5. So on calculation you will find out that this area is 314 which will give us 785 millimeters square. So this is the solution of the two given parts of this question. The third question says we have a landmass which is circular in shape with radius 56 meters. The barren land as shown in the periphery, that is this portion, is to be leveled at rupees 5 per meter square. Calculate the total cost required. Now friends, we have to calculate the cost of leveling this barren land. Let us simplify this figure. We have circle and we have as a whole 1, 2, 3, 4, 5 and 6 such pieces of barren lands. Now if O is the center, then the radius is given as 56 meters. Now since we have 6 equal portions, so this angle, that is theta, will be 360 degree divided by 6, that is 60 degree. Now this angle has come out to be 60 degree. And dear friends, if we see this triangle OAB, we have AO equals BO equals 56 meters, because both are radius of the same circle. So this triangle is isosceles, and we know for an isosceles triangle these two angles are equal, that is angle A equal angle B. Now we know that angle A plus angle B plus angle O equals 180 degree, that is sum of interior angles of triangle, which will give us angle B can be substituted as angle A. So we have angle A plus 60 degree, that is angle O equals 180 degree. So twice of angle A is 120 degree, and hence angle A is 60 degree. Similarly, angle B is also 60 degree because angle B is equal to angle A. So all the angles of this triangle OBA has come out to be 60 degree, and hence it is an equilateral triangle. And friends, we know that area of equilateral triangle equals under root 3 by 4 A square, where A is the side of the triangle, and for equilateral triangle we have all the sides equal. So if we consider one such part, that is this OBA separately, this is the barren land. Now the area of one portion of this barren land will be the area of sector OBCA minus area of triangle OBA, which is equilateral in our case. Now area of sector, we have calculated that the angle is 60 degree, so area of sector will be theta over 360 degree into pi r square, and area of triangle will be under root 3 by 4 A square. Here A and R both are 56 meters, so we have 60 over 360 degree into pi, which we can take 22 by 7. Why so? Because we have 56 and we are not given initially the value of pi. So 56 is the multiple of 7, which will be easy to cancel, and hence here, to simplify the situation, we have taken pi as 22 by 7 minus, friends, the value of under root 3 is 1.732. For simplification, we can simply take this value as 1.7 over 4 into 56 into 56. So we have 60 divides 360 by 6, and 7, here it will be 8, Now if we cancel both the terms by 2, we will get 3 and 11. So as a whole we have 88 into 56 over 3 minus 1.7, and here it will be so on simplification we will get 4928 over 3 minus 1332.8 meter squares. Or further on subtraction, it will be 309.8667, which can be simplified as 87 meter squares. The 6 is round off as 7 because this term is greater than 5. So we have calculated area of one portion as 309.87 meter squares. Now we have, friends, 6 such portions of barren lands. 1, 2, 3, 4, 5 and 6. So area of such equal 6 portions. By symmetry we can easily see that these portions are equal. We have their areas at 6 times this term. So the area will be 1859.2 meter squares on simplification. Now the cost is given as rupees 5 per meter squares for leveling this land. Therefore the total cost of 1 meter square is rupees 5, implies that total cost of this area, say it be A2 meter squares, will be A2 into 5 rupees, that is 1859.2 into 5, which on calculation will give us the simplification. It will be 9296 rupees. So friends, to level the 6th portion of such a barren land in the circular field, we will require 9296 rupees. So friends, these were some questions on sector and segment. Thanks friends for watching Edupedia Word videos.